James going to China?
All right.
No,
Oh yeah, he
Okay, we're almost done with this chapter. I think the test is next week or something, yeah?
Next week Wednesday.
Next week, Wednesday.
Wait, what? See you on Thursday.
So this chapter, I don't think you need notes, yeah?
All we do.
It's kind of easy, isn't it? Well, the concepts are easy, the computations might take a while.
Can we have a quarter of a page?
I'll think about it. Okay, today's lesson is the second partials test. Remember I was telling you about the second derivative test? The second partials test. And if you look in the multivariable calculus book, it always says the proof of this is beyond the scope of this course. So it's again, apparently very difficult to prove. So I'm not going to write the second partials test on the board. It's right there, right on the top of the page. So basically, what was that? There's a fly flying around here? Yeah. You got to compute the second partial with respect to x, call that A. Compute the mixed partial, call that B. Compute the second partial with respect to y, call that C. And D is equal to B squared minus AC. If D is positive, saddle point. If D is negative, it's a local max if A is negative, and if it's a local min if A is positive. And if D comes out to 0, that means anything can happen, which means you got to do the problem the way we did it yesterday with the H and the K. So, why don't we do the same example from yesterday? What was it? Can somebody remember it?
E.
For gradients for, which one did we do?
E.
E. Okay, can somebody remember that?
Yes.
You sure?
Yes.
And what were the answers? Oh, those just one local min.
Yeah.
Okay, that's weak then. Because I think this one, you guys are going to have to do all the problems. Okay, so what was the example from yesterday? Z equals?
X squared plus xy plus y squared minus 3x minus 3y.
Okay, so using the second partial test, we're going to have to compute, oh, first of all, we've got to get the stationary point. So do you remember what it was from yesterday?
Yes.
Yeah, what was it?
1, 1, -3.
1, 1, -3. Now, how do you, without doing the thing we did yesterday, using the second partials test, we got to compute the mixed partials. I mean the partial. So here we go. So the first one is the partial, I guess we can think of this as f, right? The partial of f with respect to x. Well, we got to do one at a time. So what's the partial of f with respect to x? Hong.
2x plus y minus 3.
Okay, and then what would be the, what's the fastest way to do that? Partial of f with respect to y, learner.
X plus 2y minus 8.
Okay, and then we'll do the second partial with respect to x, Kanashiro.
Wait, I'm confused.
What you talking about? You just gotta compute the second
Oh,
partial.
no, I'm not confused. I was wondering where the z went.
Well, z is the f.
Yeah.
It's a function of two variables.
Okay, so that's just 2.
And then the mixed partial, sum, doesn't matter which order you do it in, huh?
1.
Well, I don't like it when it comes out to numbers like that. Because sometimes you gotta actually plug in this point to figure it out. But I guess not in this easy problem. Second partial with respect to y, Park.
2.
See, it comes out to numbers. That's weak. So, this is A, this is B, and this is C. So what do we got to compute? B squared minus AC. So what is B squared minus AC? 1 squared minus 2 times 2. -3, which is negative. Which means what? We're going to have either a local max or a local min, depending on what A is. So here's A. A is 2, which is positive, so what?
Local min.
So this point here is a local minimal. A little bit easier, right, than going through the H and K thing, yeah? Okay, so it's very mechanical. Now, I did all of these problems except number 4 on the video. And I said, because usually it takes us both boards to do it, that's why. So since we have plenty of time today, why don't we do it now then? Yeah, I'm gonna erase this. So, this is very mechanical, don't need worry. So tonight's homework, number 4, it says find the maximum value of f, which is equal to, can somebody read that to me? A
X plus by plus c plus a square over x squared plus y squared plus 1.
The answer comes out really nice. It seems like every year we do this on the board, there's a different way of doing it, because usually it takes both boards to do it. But I remember one way somebody saw an elegant solution, maybe this is begin to come up with that, but I forgot what it is already. So every single year, yeah, we do it differently. So how do I figure out the stationary point? What do I need to do?
Do the thing.
The gradient. The thing. We need to know when the gradient, the x and y components of the gradient are 0. So let's just compute the partial with respect to x, right? That's the x component of the gradient, right? So who's got this one? Hong. How do I compute the partial with respect to x?
X squared plus y squared plus 1 times 2a times ax plus by plus c minus
Chain roll.
wait, I said 2a times a.
Oh, you said 2a.
Yeah.
Okay.
Minus that thingy's the top thing times 2x over the bottom thing square.
In fact, I remember one year when we did this, this is a long time ago, like 1999. Since this solution was like so huge, they actually like typed it out because it was really neat. I guess that's nobody here. Okay, partial with respect to y. Learner. Let's see if we can squeeze it in here for the camera.
X squared plus y squared plus 1 times 2b ax plus by plus c
Mm-hmm.
minus x plus by plus c x squared times 2y all over x squared plus y squared plus 1 times squared.
Okay, then that's correct. Now we got to make both of them equal to 0. Well, if this is equal to 0, that means the numerator got to be 0, right? So how do you guys want to work with that? And same thing here. The numerator over here has to equal 0. So what do you want to do? Come on, you guys got to tell me what to write here. Oh, can you see why it's going to take both boards?
I've got the x plus
Say that again.
I've got the x plus by plus c.
From this.
Yeah.
Okay, factor out ax plus by plus c. What's going to be left?
2a.
And that got to equal 0?
Just without this.
Now the square of the second part.
Oh yeah, we factored it out full. Okay, do the same thing with the other one?
Yeah.
Okay, so ax plus by plus c. And then we're going to have what, 2b x squared plus y squared plus 1 minus 2y ax plus by plus c. and that has to equal 0.
It's like the same thing, yeah, like the both Euler equations are the same thing.
Same thing except different.
So, yeah, you switch X and Y.
Yeah.
Okay, so what do we do?
If you distribute the 2a and the 2x, you can get rid of 2ax squared.
Yeah, we could have also factored out a 2 then, right?
Yeah.
So we could have factored out a 2 to make it a little easier. Okay, Lerner, what did you say?
If, like.
Distribute.
Yeah, distribute a.
So can we assume that this is not equal to 0?
No.
I think we can, because if this were 0,
Actually, it's there.
then that would be 0, and that wouldn't be a maximum value, right? Right, because we're looking for a maximum value here. So that means just this thing in the brackets that gotta equal 0. So multiplying it out, ax squared plus ay squared. Yeah, but this is just to get the stationary point. You know,
Oh,
plus a minus ax squared minus bxy minus cx equals 0. So then these cancel out. That's what you're saying.
Yeah.
And we can do the same thing on this side.
Yeah.
Okay, you guys gotta watch what I'm doing here. Ayx minus by squared minus cy equals 0. These cancel out. Okay, now what? So shall we solve for x or y in one equation and plug it in the other, or is there something clever we can do? Okay, let's see the cleverness. Because if you can't see anything, then probably solve for x in this equation and then plug it into that one. Right, because it would be difficult to solve for y because you got a y squared and a y, we're going to use quadratic formula or something like that, yeah? Or shall we solve for y in that equation and plug it in here? Or, like I said, is there something clever? I don't see anything really clever to do. I think we're going to have to plug in. No, you guys got to tell me. Like I said, every year we do it differently. I don't even remember this from last year.
I think it would be just as right to cancel out the x, y's, and then.
What do you mean cancel out the xy's?
it would be right.
Well, like multiply this equation by a,
Yeah.
multiply that equation by b, and subtract.
Yeah,
But then won't we have x squareds and y squareds?
yeah,
Still?
so then you just solve for like.
Yeah, so I think just substitution. So bx squared plus b is equal to ayx plus cy. So therefore, y equals some.
y equals to bx squared plus b over ax plus c.
Take that and plug it in here. And we're going to square it.
It's just bx squared, right?
Oh, yeah, bx squared. Will it make a difference if I factor out that b?
Yeah,
Huh?
that would be easy.
Okay, factor out.
There's that.
Factor out the b then. X squared plus 1 all over ax plus c. Take that and plug it in here. Okay, so a times that thing squared. Can we do it? B squared x to the 4th plus 2x squared plus 1 all over, maybe we should just leave ax plus c quantity squared then, yeah? What the what? Plus a minus bxy, which is b times x squared plus 1 all over ax plus c minus cx equals 0.
Factor out the.
Factor out.
The bottom.
bottom.
What do you mean factor now? Multiply both sides by the least common denominator?
X plus c squared.
So multiply both sides by ax plus c quantity squared.
Why, how would we do that?
We can?
Oh, yeah, no, we can't, it's not.
Of course we can. This is algebra. Okay, multiplying both sides by ax plus c quantity squared. So we're gonna need some room. Uh-oh. We're gonna need a chair. Give him the chair, man.
I understood that.
So a b squared, okay, I'm just gonna do it. You tell me if I make a mistake. 2ab squared x squared plus ab squared plus, oh my gosh, plus, because we're gonna multiply that by this, right? So it's gonna be a cubed x squared plus 2a squared cx plus ac squared. And then if you multiply it, then it's going to be this. I don't know if I can do that in my head. I don't think I can. Times ax plus c minus cx equals 0. No! No, who's Brett? We're going to multiply the cx times ax plus c squared. A squared x squared plus 2acx plus c squared equals 0. I don't want to go to the other side of the board because we're filming it.
Okay, just turn that.
So we got to multiply this out, yeah? Where can we go? Up there?
No, just go over here and then just turn the camera because they can just take a picture.
Turn the camera? Okay, we'll turn the camera. If I fall and get hurt, it's Tom's fault.
Oh, this camera.
Wait, move slightly there. Okay.
I think we have,
Huh? Things are gonna cancel out.
yeah.
Okay, so multiplying it all out, oh gosh. A b squared x to the 4 plus 2ab squared x squared plus ab squared, you guys better be checking, you know, plus a cubed x squared plus 2a squared cx plus ac squared. Okay, now we gotta multiply this up. Why is all this chalk on the ground? Okay, now we gotta multiply this out. So that's gonna be ax cubed plus cx squared plus ax plus c, and then you gotta distribute the negative b squared x. So what are you gonna get? Come on, you guys gotta do this. Minus
a squared x squared
a b squared x to the 4
minus b squared cx squared cube
like that.
Yep.
Okay, and then
minus ab squared x squared minus b squared.
oh, we're working on the next term now?
No,
Oh, not yet. Okay, go.
minus b squared cx minus a squared cx cubed minus 2ac squared x squared minus c cubed x.
What if C said one thing wrong?
So that's the whole thing now.
But is that
A
2ax?
squared x
Yeah, 2ACX,
Okay.
2ACX.
Yeah.
So equals 0. And then Hong said things are gonna cancel out.
The first one. the
Just
first
two
term.
terms.
Really?
No,
That's
no, no,
it?
and then.
Wait, just this and this,
No,
that's
no,
it?
and then 2ab squared x squared, and then ab squared x squared, so it becomes ab squared x squared.
Oh,
What, say what?
okay.
You're talking about this
Yeah.
And that, yeah,
and that?
yeah.
So that's
the
just
only one.
AB squared x squared? That's the only thing?
Yeah,
What if we
yeah, that's the only.
use
Please.
something incorrect?
I don't remember doing this. No, for real, I thought somebody said last year, well, you guys didn't see anything. I remember somebody said something last year, like, hey, and then boom.
Hey, we're the smartest system.
Maybe it was a who.
Oh.
Was who last year?
No,
Oh, I
Anyway, somebody noticed something, but obviously we're not. Okay, so that's it? That's all we can do? We can't combine any terms? But look, we have a cube over there. Maybe we can do some factor by grouping then.
wait.
I really don't remember doing this math here. I don't. Or maybe we did because I remember it took two sides of the board. So you know what I think we should do? I think we should put this into cubic form. So is this the only term that has a cube in it right here?
These
yeah.
negative.
Or there's another one?
Yeah, there's
There's
another
another
one.
one.
All right, okay, get rid of these then. Okay, I'm just gonna erase this. Okay, so what is the x cubed coefficient gonna be then?
Negative a squared c plus minus d squared c.
Okay, and then what about the x squared term?
A cubed plus
Well,
ab squared
Wait,
minus.
wait, 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 wait. AB squared, right,
Plus a cubed
plus a cubed,
minus a squared c. No, minus 2ac squared. Yeah.
okay, now what about the x term?
2a squared c minus b squared c minus c cubed.
That's nuts. And then what about the constants?
ab squared plus ac squared.
Say that again?
ab squared plus ac squared.
Can we do a factor by grouping? Hey, you guys gotta do the, you know what I did was it last year or 2 years ago? I put it on the test.
What?
Only
This
only one person got it. Even though you guys were supposed to do it for homework.
Wait, that on the test?
Yeah, it was the exact same problem. Everybody knows the answer, but you gotta show your work.
Wait, that would be a good investment in time.
That's why we're doing it now. Because we got plenty of time right now.
Well, no, I mean on the test.
Hey, look, I see if you factor out the a here, you get b squared plus c squared. You factor out the c here, you can get a negative c, you can get a squared plus b squared. Does that help?
No, no, really.
Not really. And then what happens if you like factor out an a here
And a c in that.
and a c there? Do you get like the same thing? And then maybe you can factor by grouping. You guys are just staring.
No, it doesn't work.
Huh?
Not the same.
Okay, so what are we factoring out from here? A. You get b squared plus a squared minus 2c squared. But over here, if you factor out c, you get 2a squared minus b squared minus c squared.
Yeah.
It's not the same. Plus, factor out the a, you get b squared plus c squared equals 0.
What is that equation? A plus b plus c.
Quantity squared?
Yeah. I don't know.
You're right. Okay, that doesn't really help. No, I remember somebody said, see, I cannot remember from year to year. Somebody said, you know, when we get to this equation and this equation, they said, hey, maybe we should have done what Kaneshiro said,
Oh, it's late.
like do elimination.
What if you equate x and y?
Say that again?
What if we,
That fly is bothering me.
wait, wait, I'm confused, what did you do?
Otherwise, you just gonna do it by yourself for homework, you know?
No.
Cause that's crazy.
I'm gonna do what you did,
What?
what Kaneshiro said.
So multiply this equation by A and multiply that equation by B.
Yeah.
Okay, let's just try it and see what happens. What happens if I multiply that equation by A?
A squared, plus A squared, minus ABXY, minus A squared.
And then what happens if you multiply this equation by B? Should we line them up?
Yeah.
Okay, and then subtract the equations? Are we gonna get something good? Maybe not, yeah. Okay, let's just try it. So subtract, what do you get? A squared y squared minus b squared x squared plus a squared minus b squared minus acx plus bcy equals 0.
That's smaller.
Huh?
Like, yeah, smaller than the top one, got that. Like AY plus BX.
What do you mean? But then, see, this equation has x's and y's in it. So I don't really think that helped. Darn, too bad we didn't video that other class. I have a video though, I think.
Wait.
Wait, oh,
Oh, okay. So, you can do, factor out a squared and then y, in parentheses, y squared plus 1, and then minus b, no, no. Wait. Is there something you can do with that?
yeah, I'm sure there's something we can do.
Oh, no, it's different sign. Here, let's just try, okay, so if you do like, factor out a squared and then in parentheses, y squared plus 1.
From here.
Yeah,
Also like group it. So like this.
yeah,
Factor out a squared. And you get y squared plus 1.
and then minus b squared.
And then you get x squared plus 1.
So that's a minus b squared, because I was gonna say like.
And then over here, factor out a c, and then you get by minus ax.
I was gonna say like, is there something you can do, because you know y squared plus 1 is, no. Let's,
If I had a
Yes,
better
I'm
memory, I
sure.
could remember what they did, but I can't. I can't remember. I can't even remember things that happened last week.
But they still have the homework.
Oh, they submitted their homework.
You haven't
But
shown
I gave it was on paper though.
all of them?
Yeah, we didn't do, I didn't do Shobi. The only time I did Shobi is when we went online, fourth quarter last year. But they didn't have MVC, fourth quarter.
You didn't do it on your homework?
No, everybody did it on paper,
Oh.
and then I handed it back. Okay, so then you guys just do it for homework then. Isn't that, come on, look, we got plenty of time. We're not going to lunch yet anyway.
Text off.
I think that's just crazy right here. That's nuts.
Yeah, I'm gonna read this.
No, there was just 1 year, because we used to take the whole board, but then 1 year somebody noticed something, and then we plugged it in, and then, oh, yeah, it comes out. But I can't remember what that is.
Oh, you did job. Notes. No, you're good at notes.
Okay, I'm gonna rewrite these equations over here, because I'm kind of giving up on this right here. So ay squared plus a minus bxy minus cx equals 0. Bx squared plus b minus ayx minus cy equals 0. Okay,
What if we did those off?
No, because I checked
it can't
I
be.
did it.
Well, it can't be, because you guys were watching me.
Oh, yeah.
It's impossible.
Did you do that last year in class?
Yeah, but I don't remember what we did. We do this every year. I know I have a video somewhere. Well, you want me to go get the video?
I think so.
No, that's weak.
Yeah.
Somebody noticed something and hey. AX equate them maybe? Or maybe we do have to just go back up to the top one. Yeah, my goodness. Okay, this let us know where, right? This one right here. Okay, let's just try factor by grouping and see what happens. What can you factor out from these two terms? X squared, right? What's going to be left? Minus cx a squared. And then what can you factor out from these two? Nothing. No, that's not gonna work.
Wait, is it? Wait, one in the middle of that. How many stationary points?
It's gonna only be, I think it was only one.
Only one stationary point?
Yeah.
Would it be drafted? It's
Sophie said she doesn't remember.
Or maybe there was a substitution that we did. Boy. We're gonna have to come back tomorrow and do this. We'll work on this for 10 more minutes.
So is this like a stationary points along like the whole parameter? Wait, I don't think there's one stationary point.
Okay, you guys work. I'm gonna try to look up something. Okay, what homework is this? Gradients what? 5.
Yeah.
Okay, there is a video. Let's see if we can learn. Let's see if we can learn anything from it.
Wait, what? That was.
Wait,
This doesn't even look like the homework.
Is that the right chapter?
It says discuss gradients 5.
Yeah.
That doesn't even look like it, yeah? This doesn't look like. This is not the right.
Hey, Seagon, let's call your brother.
Oh, come on.
That's right.
Huh? Yes, go.
Wait, can you add the two equations?
Yeah.
But like, I don't know, I haven't tried that, but like,
This is not even, the thing is labeled wrong. These lectures. Stupid.
What if we did that?
Okay, that turned out to be a bust. Let me see if I have anything in my multivariable calculus folder. Remember I told you somebody typed it up one time? I might have it here.
Mr. Clark.
Yeah, We made a mistake?
Oh, maybe not. Oh no, oh wait, oh no, never mind.
Wait, is find the maximum value?
Yeah, so we gotta get the stationary point, and then we gotta plug it back into
Wait,
the
actually-
original function.
Is find the maximum value?
Yeah,
Because I graphed it in GeoGebra and like it just kept on going up. Oh, wait, what are you
no,
saying?
no, there's an answer. What's the answer on the bottom? Wasn't it like something a squared plus b squared plus c squared? Something like that, right?
Wait, is that not answer?
Yeah, that's the answer.
I don't ever remember getting stuck like this. That I know.
Alright, try.
Okay, I can't find anything. We're gonna have to do it on our own.
Wait, Gene, can I do calculator?
No, I just solved it in a Wolfram. I can't.
Yeah, but how do you graph with the A, B, and C? You just put in numbers.
Yeah.
This works.
What?
That's fine.
What is this?
Wolfram.
I don't know. That's not it, though.
Really? The X is not this. Oh,
No.
I see B0.
Oh.
So what did you use for A, B, and C? Like 1?
Yeah.
If you use 1 for A, B, and C, then shouldn't the answer be 1 squared plus 1 squared plus 1 squared, which is 3?
Yeah, I think it was.
Did you make up this problem?
No, I got it from a book.
Then what is that book on?
Oh, this one?
No. Maybe, maybe. Wait, maybe. What book might it have come from? Here, I'll research it. You guys keep working.
So far,
Mm-hmm.
I go with Drake.
Nobody drinks anything till we solve it.
If-
Yeah, no,
if-
you can
if-
go. Wait, where are you gonna go? Oh, get one of these drinks.
Yeah.
All right, since the math team people are not coming, just make sure you sanitize the thing,
Okay.
the can.
If you gave this out of a test, will you keep the test?
No, I don't keep the test.
You don't.
Right, like if I graph it, like it goes right
Let me see what the graph looks like.
Oh.
Just x plus y plus 1 then on the top.
Oh, no, wait, no, oh,
maximum point. See? So there is.
It says one method of attacking this problem is to use the cautious swarms.
The cock snowflake.
No,
Where did you find this problem?
exceptional.
And the thing searches the thing for you?
Yeah. What?
Is to use the Cauchy-Schwarz inequality. That's beyond the scope of this class. I'm going to use the Cauchy-Schwarz inequality.
Oh, yeah, hold on.
I remember one of my professors mentioning it though.
That's crazy, yeah.
Did we even take that first place correct?
Well, you guys,
Those correct.
we did it, everything's correct.
I think.
The partials.
I think, yeah,
Yeah.
until there is correct. Check it like five.
No, I saw them and I got that.
What about like when we do this
Oh,
part,
I
is
don't know
that
that.
correct? That's correct. This kind of looks, this kind of looks familiar. And then you plug it into the other one. Maybe that's the problem right here, we didn't plug it in correctly. Wait, I'm gonna write this down because this is too interesting to let go. Okay, we will continue this tomorrow then.
Do you have like James Stewart's book?
Wait, I just want to write this part down. We don't have to start.
I thought I was doing math. He was trying to catch a fly. Yeah, I just asked them. I just asked Brandon, Sovereign, and Kenny. None of them know. Sovereign said she just burned her off on her phone.
Oh, wait. Did you ask?
Do you really? Did you really?
Yeah, I asked her. She answered. She said, I don't remember a single thing.
I bet you they don't remember this problem.
You want to ask Harry?
Okay.
I'm not really close to Harry. As much as you. Not a miracle.
Okay, we'll resume this tomorrow.
In that class.
Nobody goes anywhere tomorrow. Maybe somebody will come up with something brilliant tonight then. All right, let's go to lunch.
No cold refrigerator.
I'll work on this during lunch
Can you
too.
ask your brother?
Yeah, I asked him and he.
I would bet all the money in my wallet that Roy didn't even do this problem.